This is Uvareka from Computer Science Department. In today's class, we are going to see about semaphore concepts in operating system. First, we all know about the semaphore concept. Semaphore is nothing but it's just like a variable which is used for coordinating all the n number of activities in multiprocessors in computer systems. So the semaphore is also known as a signaling mechanisms, as well as it is also known as a just like a variable. So this semaphore concepts which are used to enforce the mutual exclusion, then we can avoid the race conditions, and also it helpful to implement the synchronization between the two processes. So this semaphore which is used to implement the critical sections. So the critical section is nothing but which are the regions of the code. It must be executed by only one process at a time. So this is the small introduction about the semaphore. Let's see the detailed discussion about a semaphore. Semaphore is a variable. It can it keeps all the wake up calls that are sent from the producer to the consumers. The semaphore can have a value. It must have a value, but it should not be a negative number. The least value for a semaphore is 0. The maximum value of the semaphore can be anything. So here in kernel mode it is a variable. So this variable can modify as well as it can read and update occurs automatically. So this semaphore variable which is dependent on the operating systems for implementation, that's why in the kernel mode only we can modify the semaphore values, we can read the semaphore value as well as the updates the semaphore values automatically. So the semaphore is also known as it is also considered as a tools, so that provides a more sophisticated ways for processes to synchronize their activities. The semaphore here named as it is an integer variable. So this semaphore variable can be accessed through two indivisible operations. So these two indivisible operations is also known as atomic operations. So one is a weight and one more is a signal. So definition of the weight operation is when some processor has already entered and executing the processor, that time the semaphore value can have a 0. If any other processor trying to enter into the critical section, before that it verifies the semaphore value whether the semaphore value is less than 0 or greater than 0. If it is less than 0, the processor will understand some processor which are executing CPU, so the processor is busy. Meanwhile it wait for some time for enter into the critical section. The existing processor has been executed successfully and come out from the processor. Automatically the signal operation will call upon by the operating system as well as it increments the value of the S. The semaphore have two types. One is a counting semaphore and one more is a binary semaphore. The counting semaphore is also a semaphore. It have an integer value and there is no restriction for the value domain. That is infinite values can have for the counting semaphores. The semaphores which are here used to coordinate the resource accesses, where the semaphore count is number of available resources. Semaphore value is nothing but it refers number of available resources which are availed in the system. If the resources are added, the semaphore count automatically incremented. If the resources are removed, the count is automatically decremented by the operating system in kernel mode. This is what the counting semaphores. The next one is a binary semaphore. The binary semaphores look like a counting semaphores, but their value is restricted to 0. Here the wait operations only work when the semaphore is a 1 and the signal operation succeeds when the semaphore is a 0. It is sometimes easier to implement the binary semaphores than the counting semaphores. This is the overall, that is the types of the semaphore concepts. The next one is what is the strengths of the semaphore? The semaphore which are usually uses the fairest removal policy, that is a FIFO, first in first out. Here basically we can define the semaphore into two types. One is a strong semaphore and one more is a weak semaphore. The strong semaphore which always uses the queues of a blocked processes. Here the processor unblocked is the one in the queue for the longest time. The weak semaphore uses the set of blocked processes. Here the process unblocked is unpredictable. So the semaphore policy here, which is distinct from the scheduling policy in a ready queue. So this is the example of the semaphore mechanism. Let's refer the diagram. Here there is a processor which is already entered in the processor, so that the remaining processes which all are waiting in the ready queue, and also the semaphore value which set as a 1. Likewise, all the processes which utilizes this processor and completes its task and releases the processor, whatever the processes which are ready in ready queue. So this is the overall concepts of the semaphore in operating system. Thanks for watching. Thank you.